Hi there and welcome. My name is Gauthier Choquet and I am a Microsoft Technical Trainer. In this module, we'll focus on the critical task of migrating SQL logins and groups using Azure Data Studio. The migration of SQL login and groups is an important step in ensuring that your database environment remains secured and that you have access control configuration are preserved during the migration process. Throughout this module, we will cover the following key components. We'll have an overview of the migration process for the SQL logging and the groups. We will have detailed steps on how to perform the migration using the Azure Data Studio. We'll look at the best practices for managing and validating migrated logins and the groups. And by the end of this module, you will have a good understanding of how to efficiently migrate SQL logins and the groups, ensuring a smooth transition and maintaining the integrity of your database securities configurations. So let's get started on the steps of database migration. Now that we have seen how to migrate the data, we need to think about the authentication component. So for a seamless and secure transition of your SQL Server database to Azure SQL, understanding and effectively managing the migration of security information is important. In large organizations, it's often better to migrate the SQL logins and groups at the end of the database migration project. This approach prevents testing delays caused by changing database schemas and allowing security configuration to align with the final architecture. Complex permission architecture can delay the migration. Migrating early can slow down the testing and complicate security validation. Also, postponing the login migration ensures that the security configuration will match the final database architecture. Azure SQL Migration Extension in the Azure Data Studio can be used to migrate logins and server roles from your on-prem SQL Server to the Azure SQL Target. These tools automate the synchronization of logins with user mapping and replicate server permission and roles. You can follow these steps to migrate logins using the migration extension in Azure Data Studio. Number one, you can launch the Azure SQL Migration Extension from Azure Data Studio and start the SQL Server Login Migration Wizard. In the step one, you can connect your Azure SQL Target, then you can select the logins from the source SQL Server instance, and then you can monitor the login migration process and view status updates. Understanding and managing server and database firewall rules, as well as the Microsoft Defender for Cloud, is important for protecting Azure SQL resources during and after the migration. So first is the server-level migration rule. Those control access to the Azure SQL database on the broad level, allowing which IP addresses can connect to the server. Then what we have is called the database-level firewall rules. Those offer more specific control within individual database. So if a database level rule is not found, then the server rule are applied. Next, we have the Microsoft Defender for SQL. So what it does is that it provides security for Azure SQL database, Azure SQL Managed Instance, but also the Azure SQL on Azure VM. It includes SQL vulnerabilities assessment and advanced threat protection. There's two ways to enable Microsoft Defender for SQL. We can enable it at the subscription level, which is actually recommended for protecting all of the databases within the Azure portal, or we can enable it at the resource level for manual management of specific databases. The SQL vulnerability assessment, which using Microsoft best practices to flag vulnerabilities, misconfiguration, excessive permission, but also unprotected sensitive data is interesting. We have the advanced threat protection. It will enhance the security by detecting and responding to unusual database access attempts. It will provide security alert for any suspicious activities, potential vulnerabilities, SQL injection attacks, and abnormal access patterns. All of those are included with the Microsoft Defender for Cloud. A database audit involves the systematic checks of the database activities to ensure compliance with policies, procedures, and compliance requirements, as well as to detect and investigate any suspicious activities or security breaches. Auditing your database is important for multiple reasons, for compliance reasons, security, accountability, but also the performance of the database. Dynamic data masking is a security feature in Azure SQL database that helps protect sensitive data from unauthorized access by masking the data at the database level. This means that the actual data is not modified, but rather masked for users who do not have the required permission to view the data on its original form. It provides a layer of security by ensuring sensitive information like credit card numbers, social security numbers, personal identification information, PII, that are not exposed to unauthorized users. There are multiple reasons why you should use dynamic data masking. First one, data privacy. It helps maintain data privacy in compliance with data protection regulations by ensuring that sensitive information is not visible for unauthorized users. Then for security, because it enhances security by reducing the risk of potential data breaches and unauthorized data exposure, especially in scenarios involving testing, development, but also analytics, where full access to sensitive data is not required. Also, very easy to use, the dynamic data masking is easy to configure and implement, allowing for quick deployment without the need for extensive changes to the application or database schema. And is very cost-effective because it provides a cost-effective solution for protecting sensitive data, as it does not require any additional hardware or software investment. By leveraging data masking, your organization can reduce their data security exposure and ensure that sensitive information remains protected even in complex database environments. So how do we do it? Well, it's very simple. So within the Azure portal, you select the database, you choose the database to configure from your list of databases, then you navigate to the dynamic data masking option, you add the masking rules, you click on Add Masking Rules, and then you can define the rules by selecting the schema, tables, column, and mask function. And then you save the rules. You review it, apply the masking rules, and then you can monitor and also adjust as needed. Setting up the dynamic data masking is very easy, user-friendly, and will enhance security quickly and efficiently, making it an ideal solution for protecting sensitive data. With the successful migration of SQL logins and groups, the next important step is to ensure optimal performance and security to continuously monitor the database performance. So let's go ahead and see what we can do around monitoring. The good news is that whatever you have learned from monitoring and troubleshooting techniques with traditional SQL Server environment remain consistent in Azure SQL. Tools like Performance Monitor are applicable for SQL Server on Azure Virtual Machine. For the Azure PaaS solution, specific tools are available. Collect monitoring data like CPU usage, response time, transaction rates, error rates, and more. So before the migration to serve as a reference point for post-migration performance evaluation. Okay, so it's always a good idea to compare post-migration metrics with pre-migration baseline to identify potential performance issues, which help in understanding the migration's impact and room for potential optimization. Automatic tuning uses query stores data to identify potential issues and improvement. It also offers recommendations and can autonomously apply them, enhancing query performance by tuning indexes. Azure SQL databases support automatic index tuning, providing recommendations on adding or removing indexes based on workload performance. It monitors resource availability to prevent performance degradation during the creation of the index or even its removal. You can set up performance alerts for databases in Azure SQL Database using the Azure portal. Those alerts can notify you via email or even call a webhook when you reach specific metrics like the database size or CPU utilization. Think about it. We may have some highly transactional database with high IOPS utilization against the disk. By default, Azure monitors every single resource that is being deployed. But if we have some specific metrics that we want to monitor, we may want to address them proactively. As mentioned, Azure does a great job at monitoring all the resources that are being deployed in your subscription. By default, Azure collects basic telemetry data for your Azure SQL database. You can also enable the collection and analysis of telemetry data for additional monitoring with pre-built visualization. All right, so now that we've got a good monitoring framework and automatic tuning set up for your Azure SQL database, let's talk about high availability and disaster recovery option for the PaaS solution. So it's important to keep in mind that having the data accessible and safe even during disruption is important to us. So Azure offers multiple high availability solutions that help keep their services running with minimum downtime. Those include built-in replication, automatic failover, and geo-redundant storage to protect your data across multiple regions. The disaster recovery service helps you to restore operation after a major incident. The Azure PaaS come with advanced recovery features to quickly get your database back to their original state prior to the issue, minimizing the data loss and downtime. So let's look on how to set them up and use them effectively to keep your data secured and keep your services up and running. When we talk about the backup and the backup strategy, there's a lot that can be said. We can talk about different metrics like the RPO and the RTO. So the RPO, recovery point objective, refers to the maximum acceptable amount of data loss measured in time. The RTO, the recovery time objective, is the maximum acceptable amount of time to restore the database after a disaster. Now, how do we set it up? Well, again, Azure Backup is a managed component for the Azure SQL, meaning that it can be set up in just a few clicks. There's no need to have script for full backup, another script for the differential backups, or even one for the transactional backup. Just use the Azure policy to set it up and specify how often and how long you want to keep those backups. Is a backup the same as a replication? Well, not really. And also, should we replicate our backups? Well, that sounds like a good idea. Placing our backup in a single location can be a single point of failure. Imagine that I place all of my backup in a single location, and let's say there is an outage at that specific location. Well, you guessed it, right? You will not have access to that backup. Now, would the replication of our backup fix the issue? Well, if I synchronize my backup across two different locations, then it helps me to be protected against the outages or any scheduled maintenance. But what if our data gets corrupted? Well, the corruption will be replicated as well. That's why combining geo-replication and backup with the point-in-time restore is a great combo. We now talk about immutable backup, where your backup file cannot change over time and it cannot be corrupted. So ideally, this is what we want. There are multiple approaches to achieve high availability across regions. There's active passive with cold standby, where the traffic goes to one region while the other region waits on cold standby. The cold standby means that the resources in the secondary region are not allocated until there's a need for failover. This approach costs less to run but will generally take a little bit longer to come online during a failure. Second approach is the active passive with hot standby, where the traffic goes to one of the regions while the other region waits on a hot standby. That means that the resources in the secondary region are already allocated, they are running, but they are not receiving any traffic yet. And then we have the active, where both of the region are active and receiving the request through a load balancer or else. So if one of the region becomes unavailable, then it's taking out of that rotation and the traffic is already distributed on the other region. All right, so let's now have a look at the Azure Auto Failover group. This feature works for both Azure SQL Database and the Azure SQL Managed Instance. It's aiming to keep your database highly available by managing replication to another region and automating the failover process. Here is how that works. There is a listener function that handles both read and write and the read-only activities. When a failover happens, the DNS will be updated automatically, so your clients connect to the right listener name without needing to know any additional details. So basically, the primary server hosts the read-write copies, while the secondary server is here to receive the transaction from the primary. There are two types of policies you can set up. Number one, the automatic way. So the system will automatically trigger a failover if it detects a problem. You can turn this off if you want. And then the second option is the read-only. By default, the read-only traffic is disabled during a failover to keep things running smoothly, but you can enable it if needed. One component to take note is that the secondary database is created automatically through a process called seeding, and this can take some time depending on the size of your database. So we need to plan for that. All right, so in this demo, we will enable geo-replication for an Azure SQL database. This demo is designed to provide a comprehensive hands-on experience, allowing you to understand and implement the critical steps required for ensuring the resilience and high availability of your SQL database across regions. You will learn how to create a replica of your database, set up new server for the secondary database, and then perform a failover to a secondary region. Additionally, you will gain insight into monitoring the status of your deployments and understanding the role of geo-secondary or geo-replicas in Azure SQL Database Management. So let's go ahead and let's do it together. All right, so welcome back for our last demo for this session where we're going to talk about the geo-replication for Azure SQL databases. So multiple steps that we're going to be doing in order to enable those geo-replication. So first of all, we're going to create an Azure SQL database with its logical server, and then we're going to create another logical server into another location, another region. Then we're going to enable that geo-replication, and we're going to actually trigger a force failover into the secondary region. Okay, so very interesting component here. The demo is not going to be as long as the previous one here. So let's get started. And the reason why it's not going to be long is because as we have not done it yet, or for this demo, we are going to deploy the resources with the Cloud Shell. Okay, so it's not something that we have done yet. So in order to do it, well, let's go ahead and we can open the Cloud Shell with this icon right there on the screen. All right, perfect. And then we're going to open the bash. Okay, so it's asking here for the first time we open the Cloud Shell is actually asking for us to have the option to create a storage account or not, right? So I'm going to do the option to not storage account is required. Okay, it's still going to have to select the subscription as part of this. Apply, perfect. And now we have the Cloud Shell. Okay, so now what do we do next? Well, I'm going to be using and leveraging a provided script, right? So think about it. So there's multiple ways on how we can deploy the resources. So far, we have seen how to deploy the resources through the portal, right? And now we're going to be using script. So potentially here, we're going to use the bash command here in order to deploy our resources with the command line, right? So why is that interesting? What are the benefits? Well, once again, think about if you want to add automation into the picture, right? So if we have as part of our life cycle for application, if we need to deploy our resources over time, do we want to do it manually directly on the portal? Well, we can, that's an option, but can we automate this and just trigger a script? Yes, as well here. So that's the intent of that demo as well, is how to deploy the resources with a script. So in order to do this, I'm going to open the now notebook, okay, the notebook, the notepad. Potentially we could open on the Visual Studio as well. Just going to open on the notepad here, and I'm going to send the script that I have, which is coming with some default value that we need to change, right? So you can see here we're going to need the subscription ID, the resource group, the location where we want to deploy the resources. We have the server name already that's being provided, the admin login, the password that we need to update, and so on, right? With the database name, which is already provided. So first of all, what we need is the subscription ID. So how do we find it? Let's go back to the Azure portal. I'm gonna search for the subscription. All right, subscription, locating my subscription ID. Be careful about the quote and the bracket. Then we need to have the name of the resource group. Going back to the roots here. Resource group, we should have one that's already provided. Pay attention to the location. Again, this one is being deployed on East US 2. Gonna leverage this as well. Okay, so I just copy the name of the resource group itself. When you work with script, once again, be careful with the bracket and the code. So I don't need the, I just need to keep the code, but not the bracket. And be mindful about any space. So if I have a blank space here, potentially that would impact my command here, okay? All right, so we continue. We're gonna go next here for the location. So location of, I'm gonna keep the one at the region, right? That is being used for the resource group. Okay, so East US 2. Now, remember, we're going to create two different server name. Okay, so the first one, we have that SQL Server 1 plus that number behind it. Here, there's the admin login, SQL admin. Then we need to create our secure password here. All right, so potentially the one I'm going to be using here would be, go ahead, type it. All right, DP300 password. Okay, so be mindful that it needs to be aligned with the complexity required for the password for SQL databases, Azure SQL databases here. All right, so here you go. I'm gonna just double check here my values. I have the subscription ID, the resource group, location, East US 2, server name, admin login, password, and the name of my database. Perfect. So what is it going to do here? It's going to, run a couple of commands here. That's what we're going to be doing as part of the provisioning through the portal here. All right, so let's go back on the portal. So now I'm going to open the editor. Do you want to switch classic cloud shell? Well, yes, potentially. Okay, so I'm going to create a file where that I'm going to save as a script. All right, so let's open it. Okay, perfect. So I'm going to paste what I just had here, right there, on the editor that we can see. Okay, just double checking if we have all the values. Perfect. So now we're going to do a right click, save. I'm just going to save it as script1.ps1. Okay, be mindful that you actually need to have the extension here as a .ps1 file extension. Okay, all right, so let's continue. Save. So now we can see that the script has been saved as script1.ps1. Okay, so now I'm gonna run the command here with the script name. So I need to update this with the script1.ps1. All right, so what does that do here is that is making the change on the permission of the file to make it as executable. Okay, so now because of that, now we can execute that script. All right, so once again, let's run that command. I just need to modify the script name with my script number 1, removing the bracket. All right, perfect. It's starting, it is running. So what is it doing right now? Well, it is deploying the resources. It's gonna take few minutes here to create the database and the database server with the logical server. So let's wait for that. And then after, we're gonna double check what has been deployed. All right, so it looks like the deployment is now completed. So let's have a look. So I'm gonna just go out there and refresh. So we're in the scope of the resource group. So let's go and refresh. And we can see that we have our 2 resources being deployed. So we have the logical SQL server and its database running on it here. All right, so potentially here now we can have a look at the database and the server itself for more information. Okay, we can see we have the server name once again. Right, potentially what we're going to do here is looking at the access, configure the access. So selected network, perfect, that's what I want. Okay, and also we'll add the client IP, save it. All right, so perfect, everything is safe. Now, what do we do next? So what we have so far, as mentioned, is that we have that SQL server running on EastUS2, which is one location, and then we have its database running from it. So the goal of this demo is to enable the geo-replication. But for that, we need to, the geo-replication, for the geo-replication, we need to have another underlying SQL server, the logical server against another region. Okay, so this is what we're going to be doing right now. We're going to be deploying a second, by leveraging the script that we have, we're going to deploy a new SQL server. Okay, so before we had the SQL server 1, so now what we're going to be doing is that I'm going to change this value. Potentially I could have just typed the number 2 as part of it, but let's type it completely. There you go, SQL Server 2. Okay, so it's not going to be the same one. Now, can we have geo-replication within the same region? Well, no, right? So that's why as part of this creation here, I'm going to change the location, changing it from EastUS2 to EastUS. Okay, now I'm going to keep the same admin login and the same password as part of this creation here. All right, so the only change that I have here is going to be another location and another server name. Also, I'm just going to create the logical server. I am not going to create the database itself. Okay, so I'm removing the last line on the command line, right? The AZ SQL DB create, okay, because I'm just creating the underlying logical server for it. Okay, the creation of the database itself will be done through replication a little bit later. Okay, so here that looks like a good script to have. So let's bring it and we're going to repeat the steps. So let's go ahead. I'm going to open the Cloud Shell and then edit the file. Yes. All right, so we open it here to open the editor. All right, paste. Let's double check the values that we have. Okay, so we have the location moved from EastUS2 to EastUS and the server name, which is pointing now to the SQL Server 2. All right, so this is good. This is what I wanted to have. So now what I'm going to do, right click, save, and then I'm just going to call it script number 2. Script 2.ps1. Okay, so it's just a repeat of what we've done previously. Script 2. All right, so now it's going to create It's going to create provisioning of our server name number 2. Okay, so it's not creating the database. We're going to have a look once it's completed. It is only creating the logical server. All right. So let's wait for this. And then after, we're going to double check what has been provisioned. All right, so the deployment is now completed. So let's see what has been deployed. I'm going to refresh the scope of the resource group once again. So previously we had those the server 1 and the database being provisioned. So let's go ahead and refresh. So now we can see that we have the server 2. Okay, so as a repeat, I'm going to open it. I'm going to go on the security networking to add the client IP as we have done before. All right, perfect. Save it. Why do we need to add this? Well, because we're going to connect to it, right? So actually, now that I've been creating those here, so what do we do? Well, we can enable the geo replication, right? That's what we can do. So let's do this. So I'm going to create the SQL. I'm going to look at the SQL database that's been created. So how many, when I click there, how many would I see? Well, the answer to that is 1, right? So we have 2 logical servers, but we have only 1 database that's been created on the server 1. Okay, so far we're consistent. Here, this is the name of the logical server, and then here, this is the name of its database running from it. Okay, so under data management, we have the option here to enable the replica. All right, so right now we have none. So we're going to create a replica, which is, as we can expect, going to be pointing from the server number 1 to the server number 2. Okay, that's the intent right here. So we have the primary database, AdventureWorks LT in the region East US, pointing to the second database detail, right? We need to change it to point to the server 2, as explained before, right? So it's going to be pointing from that specific database that we have, AdventureWorks, to that server 2. Okay, so it's going to be creating a database as part of its replication. All right, so let's do it. Review, create. All right, submitting. Perfect. So it's creating. In the meantime, what I'm going to be doing is that I will go and open a new tab here on the Azure subscription. And what I'm going to be doing is that I will go check what is running directly on that database. All right, so let's go ahead. Gonna look at the replicas, and we can see, look at this. The primary AdventureWorks running from that server 1 is online, right? The database was up and running, and then we are enabling the replica. So right now it's not completing. The seeding is at 0%. And then the first 0% is actually one of the longest percentage. So once it's there, the synchronization, right now what it's doing, right, it's preparing for the seeding, and after we're gonna have a constant replication, constant synchronization between the primary database against the one that is being replicated. All right, so let's wait for that. All right, so the deployment is completed. So let's have a look. Okay, so we are now connected to that SQL Server 2, and the database AdventureWorks LT has been created as part of it. Okay, so we didn't create it, but can we connect to it? But potentially yes, right? So can we connect the secondary Azure SQL Server? Let's go ahead and do it. So I'm going to open the SQL Management Studio, and then we're going to connect that secondary Azure SQL database. All right, so I copied the name of it. In the meantime, I'm opening the Management Studio. I'm going to be using that SQL authentication with the information that we provided earlier. So I add my SQL admin, and then I add the password that we placed earlier. All right, perfect. So now we connected. I'm going to expand this a little bit. And then now we can see that the database is there, right? So we did not create a database. That database got replicated. Okay, so we had that constant synchronization of, we have the constant replication right now because it's part of that geo replication, right? So very interesting here option that we have here. Okay, so got created with it. Now, what can we do with it? Well, that's interesting because it's when we go on the replication here, what do we have? We can see that the primary is online, and then the one as part of the geo replicas, the one I've access to, which is deployed in EastUS, the one I'm connected to through my management studio, is readable. So can I do anything against it? Well, yes, I can read information as I was opening it a few seconds ago. Now, can I write data? No. Okay, so, but potentially think about situation where may have some outages. Let's say what's going to happen if we have only a single endpoint as part of EastUS2, and then there's some outage against EastUS2 region. Well, in that situation, if we do not have any replicas available, we will lose access to the database. Okay, so when we think about continuity of our services and minimizing downtime, that's when the geo-replication will come into play, right? Because if there's any issue against the EastUS2 detected, Azure will automatically fail over if needed, right? In order to minimize the downtime. Would we get any downtime? So I'm going to simulate here force failover on my side. Would we get any downtime if there is a failover? Well, yes, right? Potentially there is, because of that synchronization time, which is up to 15 minutes, there is some potential data loss, right? So here, because I'm doing that force failover, it's telling me like, hey, potentially here you're going to get some data loss. Are you sure you want to proceed? Yes. Let's continue, right? Request submitted for failover. And then now is going to be all the open connection that we have against the primary are going to be dropped. Okay, they're all being disconnected during this force failover. And then now if we refresh, right? So the status here is pending, so we cannot connect to the primary. We cannot connect to the geo replicas here. I'm going to keep refreshing here until we can see the online. Okay, so it may take a few minutes. Let's wait for it. All right, actually already done. So you can see that now the primary is online, but now the primary is the one running on the server number 2, and then the server 1 is now as readable because it's part of the geo replicas here. Okay, so very interesting. And now I know we've talked on our previous discussion on having, so this one is a active passive type of scenario. So is that something that meets your requirement? Well, maybe. Now we have seen that potentially we can even reach an active scenario, right? So as part of previous discussion. So independently of what is needed, Azure once again does a great job to providing us with multiple options, and then this is one of those options for business continuity. All right, so hopefully you like it. Hopefully you enjoyed that demo here. As a good reminder, always good to clean our resources once we are done. So completed with this demo, what we have done, once again, is creating multiple Azure SQL databases with their servers through script, right? So that's what we have done. Then we have enabled the geo-replication, and then we have done a failover against that database to that secondary region, all right? And then, as mentioned, once you're done with your resource, always good reflex to delete what is not needed. All right, so this step here will help us to delete everything. Okay, I'm gonna let it run and hopefully you enjoy it. And then thank you so much for watching. Thank you. In this module, we cover the key components of migrating security information during the transition of SQL Server database to Azure SQL. By understanding and implementing these strategies, you can ensure a secure, compliant, and highly performing migration of your SQL Server databases to Azure SQL. Thank you for watching.